Good morning, Algebra 1 class. I hope you guys are having a great week so far. I hope that you guys are understanding your material okay. And if you guys have any questions, please again, feel free to message me on Remind, and I'll be more than glad to reach out to you guys. Alright, so we're going to go ahead and start today's lesson, which is lesson 8.3, Multiplying Binomials. So for this lesson today, you're going to need some paper to take notes because you're going to want to practice these, pencil to write things down with, a basic calculator, so just do adding, subtracting, multiplying, dividing, and need your textbook. We're going to start on page 498, and you will need your homework 65 at the end of the lesson that you guys will be working on as well. So we're going to go ahead and get this ball rolling. You may pause it if you need to collect your things. All right, here we go. All right, so we're going to start with our first example. So example 1. And we have 4 different types of things we're going to learn today in this lesson. So just be prepared, and you can pause and come back to it as you need it. You can do a little homework and whichever helps you understand better. So please use this to your best learning ability. So first we're going to talk about is using the distributive property. So this is something that you guys have already learned before. Using the distributive property. Now we've kind of already done something like this before, so this shouldn't be too terribly new to you guys, but we're going to show it to you in a way where we have binomials, which means now we're multiplying a 2-term times another 2-term. So we're going to start with the example they give us, which is 2x plus 4, and we're going to multiply it by 3x minus 7. All right, so here's the example they provide us in your textbook on page 498. So we're going to use a distributive property, which means we're going to distribute this 2x to the 3x, and we're going to distribute this 2x to the negative 7. So what they mean by that is we're going to take that 2x, and we're going to multiply it times the 3x. Since our 2x is positive, I'm going to put a plus sign here, and I'm going to take that 2x, and we're going to distribute it and multiply it by the negative 7 over here. All right, since our 4 is positive, I'm going to put a plus sign and do 4 and distribute it times the 3x. And again, since our 4 is positive, I'm going to put a plus 4 and distribute it to the negative 7 down here. So distributive property. So we use a different color here so we can show. We distributed the 2 times the 3x, and then we did the 2 times the negative 7, and then we did the 4 times the 3x, and then we did the 4 times the negative 7. So that's kind of what we did with the distributive property. So now we're going to go ahead and multiply each of these individual sections. So first section, we're going to multiply our coefficients always first, and then your variable second. So we got 2 times 3, which is 6. And remember, when we multiply, we add our exponents. So there's a 1 here and a 1 right there at that x that we don't see. So this is the same as x to the 1 plus 1, because remember, we're adding those exponents. All right, so now here we've got a positive 2 times a negative 7. Well, we know that a positive times a negative is a negative, and then we have 2 times 7, which is 14. And since we just have the x comes down. There's no x to multiply it with the 7. So now we're going to keep moving. We got a positive 4 times a positive 3, which makes a positive 12. And then we just have the x. We have to bring it with us because there's no x to multiply this x by. There's just the single x. Now we have a positive 4 times a negative 7, which makes a negative 28. So now we're going to go ahead and we're going to rewrite this for 2 ways. One, we're going to combine these exponents right there, 1 plus 1. And then we're going to notice that right here in the middle, we have some like terms. They both contain the variable x. And so we're going to combine those like terms by using whatever sign is to the left of them. So let's go ahead and rewrite that then. So we got 6x squared because 1 plus 1 up here makes 2. To find this next term, we have to combine these two together. This is a negative 14, because remember, the sign to the left of it indicates whether it's positive or negative. So a negative 14 plus 12 is a negative 2. So there's a negative 2x's. When we add and subtract, we never mess with the exponents. Only when we multiply or when we divide do we mess with these exponents. Then we just bring down our minus 28 because it's the only constant that we have. So this would be your final answer. All right, we're going to try the got it 1 on the bottom of that same page. And we've got x minus 6 times 4x plus 3. So this is our first method. It's called using the distributive property. So we're going to take the first term which we have, which is x, and we're going to distribute it to the 4x. Since my x is positive, I'm going to write a plus sign and distribute it to the 3. And it's positive, so I just write positive 3. I have to write plus 3. Now I'm going to distribute this negative 6. See, the 6 is negative. So since it's negative, I'm going to put a minus sign, 6, and distribute it to the 4x, who is positive, so just 4x. I got to distribute this negative 6 to the 3. Since it's a negative 6, put a minus sign. And I'll distribute it to my 3, who is positive, so just write a positive 3. All right, so I'm going to slide this up a smidge. So now we're going to go ahead and do our multiplying. But remember again that when we have the exponents, they're not there, they're understood ones. And there is an understood coefficient of 1 right here in front of that x. So we're going to multiply our coefficients first. So 1 times 4 is 4. We've got our x, and then we have 1 plus 1 for adding those exponents. Now here, there's a 1 in front of here we do not see. So a positive 1 times a positive 3 is a positive 3. We only have one variable, so it comes with us, because there were no other variables to multiply it by. Now we're going to take our negative 6 times our positive 4, and we'll get a negative 24. And then we'll have x because it's the only variable there. Then we'll multiply negative 6 times 3, and we'll get negative 18. So now we're going to go ahead and rewrite this and combine our exponents. And we'll notice that the 2 in the middle, again, are like terms. And we multiply two binomials, for the most part, that will always happen. So here we go. Got our 4x, and we're going to add 1 plus 1, making it a 4x squared. We use the signs to the left to indicate what they are. So here we have a positive 3 minus a 24. So 3 minus 24 is equal to a negative 21x. And again, we don't mess with the exponents because we're only adding and subtracting. The only time we touch them is if we're multiplying or dividing. Then we bring down that constant of negative 18, and here is our final answer. So this is method number 1, using our distributive property, but now we've learned to do it with a binomial, which is 2 terms, times another binomial, which is also 2 terms. So if you like that method, that is awesome. But I'm also going to teach you another method, just in case you might like it better. So I move this screen up a little bit so we can kind of get into here. All right, we're going to be at the top of page 499. We're going to do method number 2. So example 2. And this is called using a table. Using a table. Now some of you may like this. And if you like the table method, please feel free to use it. You will get the same answer regardless of however you so choose to do so. So we're going to start out with the problem they give us, which is x minus 3 times 4x minus 5. All right, so what they do is they create these table of values. So I'm going to go ahead and try to create a little table for us. All right, so first of all, we come across the top here. I'm going to come down And in this box, we're going to take this side over here will represent our x minus 3. So this will be our x, and this would be our minus 3. Then we're going to come across the top up here. This top part right here represents our 4x minus 5. So I'm going to go ahead and put my 4x and draw my line. And then we have our minus 5, which is here. We'll go ahead and put our little lines in here. Now these little spaces right here we don't need. They're kind of blocked off. And these little spaces down here are all kind of blocked off, so we don't need them. So that's not important to our little chart. Okay, so this is kind of what your table looks like, except it's green. So what they did is they multiplied x times 4x and got 4x squared. Then they multiplied x times negative 5 and got negative 5x. Then they multiplied negative 3 times 4x and got negative 12x. Then they multiplied negative 3 times negative 5 and got a positive 15. So from here, now they write everything over to the side, and they're going to write it in order, starting from the first row. 4x squared minus 5x. Then they go down to the second row. Minus 12x, and that's a positive, so plus 15. So from here, you take your guys that we see in the middle, just like before. Those are like terms. They both contain the same variable x to the same power of 1. So we bring down our 4x squared because it's the only value up here raised to the x squared. We take a negative 5 and we minus 12 more and gives us a negative 17x and then plus 15. This is method number 2 using a table. All right, we'll try one more of those. So I'm going to go ahead and change the paper because we won't have enough room. So we'll bring this back down. And I'm going to go ahead and change the paper out. And we'll do one more of those. Just around. All right, so we're going to do another one using that table method again. So we're going to do the got it 2 just underneath that second example on page 499. So we got 3x plus 1 times x plus 4. All right, so we're going to do our table chart. Again, this side represents the first polynomial, 3x plus 1. So we're going to put our 3x and our positive 1 right there. Then this top part up here represents our second polynomial of x plus 4. So we'll put our x and then our 4. And remember, we don't use this part. And this part as well. Okay, so then we're going to go ahead and we're going to distribute. 3x times 1x makes 3x squared. 3x times 4 makes 12x. 1 times x is 1x. And 1 times 4 is 4. When we go off to the side, we start writing the first row. 3x squared. It's a positive, so plus 12x. Then we start with the second row. That's a positive x and a positive 4. And just like our previous problems, the 2 in the middle are our like terms of which we combine because they both have the same variable x to the same power of 1. So we bring down the 3x squared because up here there are no more x squareds to add it to. 12, and there's a 1 here we don't see, so 12 plus 1 makes 13 x's, and then we bring down our plus 4. And here would be our final answer. All right, I hope you guys are doing okay so far. All right, so now we're going to go ahead and teach you the third type of method. So bring this up. So example 3. Is called the FOIL method. Now the FOIL method I'm hoping you guys can connect and see it kind of looks very similar to a method I've already taught you before, but we're going to show you how this works. Now, FOIL only works when you use this method only, it's very important, only works when multiplying a binomial times a binomial. That is the only time you can use FOIL. You cannot use it any other time. It does not work. All right. So for FOIL, each of these letters stand for something. You kind of like an acronym. So we're going to teach you. So F stands for first terms. All right. The O stands for the outside terms. The I stands for the inside terms. And the L stands for the last terms. All right, so this is what FOIL means. This means they want you to multiply the two first terms together, then they want you to multiply the outside terms together, then the inside terms together, and then the last terms together. I'm going to show you what that means with a given problem. All right, so we're going to do 5x minus 3. And we're going to multiply it by 2x plus 1. All right, so we're going to do our FOIL method. So let's start with our FOIL, our first. So the FOIL, the F, the first terms. So we first have to determine who are the first terms. So if we look in this first binomial, who is the first term we see? Right here. That's our first term. So if I multiply these two together, these are my first terms. The first term in the first set is 5x. And I'm going to multiply it by the first term in the second set, which is 2x. I'm going to multiply those first terms together. So when I do that, I get 5 times 2, which is 10. And then remember, these have exponents of 1, so it's the same as x to the 1 plus 1. And we combine those exponents, so we get 10x squared. So that's when I multiply the first term together. All right? So the outside terms are the two on the far outside. So this 5 is on the far outside, and this 1 is on the far outside. So outside terms, O, are the two numbers on the far outsides. So that's 5x times 1. So if we multiply 5x times 1, we get 5x. So let's bring that over, 5x. All right. Then we're going to go ahead and multiply the inside terms. The inside terms are the two on the inside. So this negative 3 is on the inside, and this 2 is on the inside. These are our inside terms. So negative 3 times a positive 2x will give me a negative 6x. So I'll bring that over, negative 6x. Then we'll multiply our last terms. The last term are the last term in each set. So negative 3 is the last term in this set, and 1 is the last term in this set. So we'll multiply those together, creating my last terms. So my last term is negative 3 times positive 1, which is a negative 3. So bring that over, negative 3. So now I can rewrite my problem. So I've got the top, 10x squared, a positive 5x, a negative 6x, and a negative 3. I'll bring this up so you guys can see, sorry. All right, so now just like the previous problems, these two middle guys will combine. We'll bring down our 10x squared. 5, take away 6 is a negative 1x. We just write it as negative x. And then we have a minus 3. This is our final answer. So who can tell me what they think this FOIL method might be similar to? That's right, Connor. It's very similar to our distributive problem. property. So remember with our distributive property, we multiplied 5 times 2, which we did. Then we did 5x times 1, which we did. Then we distributed the negative 3 times the 2x, which we did here. And then we did negative 3 times the positive 1, which we did here. So the FOIL method in a binomial times a binomial is the exact same thing as the distributive property. It's just worded differently. All right, so we're going to do another one of those. I'm going to bring it down here and see if we can make sure, just in case you're one of those students who really likes this FOIL method and you want to use it, I want to make sure everyone gets a chance to see it. All right, so we're going to do 3x minus 4. So I'll bring this over. 3x minus 4. We're going to multiply it by x plus 2. All right, so we're going to do our first term. So we're going to do first term together. So who would be our first term? That's right, Brennan, 3x. And I'll multiply it times the first term over here, which is 1x. So 3x times 1x is 3x squared. Now we're going to multiply our outside terms. So our outside terms are 3x over here, outside, and all the way down out here, 2. So 3x times 2, which is 6x. Then we're going to multiply our inside terms. So it's negative 4 times x, so negative 4 times x, which equals negative 4x. Then we're going to multiply the last term. So the last term in this set is negative 4 times the last one in this set, which is a positive 2. So negative 4 times positive 2 is negative 8. So we just come over here to the side and rewrite them. 3x squared, positive 6x, negative 4x, and negative 8. And then we'll combine the two in the middle because they both have the same variable x to the same power, which makes them like terms. So we bring down that 3x squared, 6x, take away 4 is a positive 2x, and then our minus 8. Final answer. All right, so that is our third way of doing these binomials times a binomial. We have distributive property, we have the table method, we have the FOIL method. So now, I told you FOIL method only works, remember, when we are doing a binomial times a binomial. The table method and the distributive property can work either way. The only one that you can only use on a binomial times a binomial is FOIL, because it's the only way you would have first, outer, inner, last. That's the only way that occurs. All right, so our final thing that we're going to talk about today has to do with a monomial and a trinomial and a binomial and a trinomial. So we're going to jump right to the multiplying a trinomial and a binomial because you have already learned multiplying a monomial times a trinomial in the last. So our fourth example for today, I believe it's our fourth. Might only be our third. Oh, it is our fourth. Yay! Miss Hebert, you did good. So example 4, we're going to do multiplying a trinomial and a binomial. All right, so we're going to multiply a trinomial, which is how many terms? That's right, Addie, it's 3 terms, times a binomial is how many terms, Heather? That's right, 2 terms. So we're going to multiply 3 terms by 2 terms. All right, so I'm going to show you a couple ways to do this. So you can decide which method that you like best. So we're going to start out with the given example that they give us, which is 3x to the second, so 3x squared. And then it's plus x minus 5. That's our trinomial because it has 1, 2, 3 terms. And we're going to multiply it by a binomial, which is 2x minus 7, which again, this has 1, 2 terms. All right, so I'm going to show you the distributive property first. Then I'm going to show you the table method. and then I'm going to show you the way that looks like a regular multiplication problem. So there's 3 ways in which you can solve this same problem. And again, you have to pick the method that you feel most comfortable with, because all 3 methods will result in the exact same answer. All right, so we're going to do distributive property first. I'm going to write distributive. We're going to solve this first using the distributive property. All right, so we're going to take our first term, which is 3x squared, and I'm going to multiply it by the first term I see over here, which is 2x. I'm going to distribute it to the 2x. Squared is positive. I'm going to put plus, and then my 3x squared. I'm going to multiply it by this negative 7 down here. Then I move over to the next term, which is a positive x, so I'll put a plus sign. And I'll multiply it by the first term I see right here, which is 2x. Then since it's positive, I'll put a plus. I'm going to multiply it by this negative 7, so I'll put negative 7. I'll take my final term, which is negative 5. Since it's negative, put a minus sign, so negative 5 times my 2x. And then I'm going to take my negative 5. Sorry guys, I about had to sneeze there. Times my negative 7. Alright, so now we've got 1, 2, 3, 4, 5, 6. So now I'm going to go ahead and do all those multiplying to make sure everything works good. So remember, there's little exponents with 1s that we don't see. So we'll put little 1s up here with all these little plain x's that we need to multiply with that are important. Alright, so we multiply. Remember, we're going to add the exponents. So we got 3 times 2, which is 6. Our variable is x, or the base is x. And we'll add the exponents. 2 plus 1 make 3. Alright, so now we got a positive 3 times a negative 7, which makes a negative 21. And we only have one variable, and it's x squared, so it comes down, x squared. We're going to multiply. There's a coefficient of 1 we don't see, but right there it is, understood. 1 times 2 is 2, positive, so we're going to positive 2. And then we got x times x, which is x to the second. Then we're going to multiply our coefficients again. 1 times negative 7, which is negative 7. I'm going to bring down the only variable that's there, which is x. Then we're going to multiply. Negative 5 times positive 2 is a negative 10. And we'll bring down the only variable that's with it, which is x. Then we're going to multiply the last. Negative 5 times negative 7 is a positive 35. So now in here we have a couple things that are like terms. We have this has an x squared and this has an x squared, which makes these guys like terms. And this has a plain x and this has a plain x, which makes these guys like terms. So we're going to combine those like terms. So we don't have any other x cubes besides this 6x cubed. There's no x cubes anywhere else throughout this problem. So we're just going to bring down our 6x cubed. We're going to combine our x squareds. So negative 21 plus 2 is a negative 19. And those are x squareds. And again, we don't mess with the exponents because we were not multiplying or dividing. We were just adding or subtracting. Then we're going to look over here at our x's. We have a negative 7. Take away 10 more makes a negative 17x. And again, we keep it just plain x because that's what they were. We don't mess with the exponents. We were not multiplying or dividing. We bring down the plus 35. All right, and that would be our final answer. All right, so we're going to do the table method. All right, so table method. I may have gone down too far, but that's okay. So on this side of our table method, I'll bring this up a little bit, represents our first term, which is 3x squared plus x minus 5. So 3x squared plus x and minus 5. Yeah, I got a little carried away there, but that's all right. Then on the top column, this is going to represent our second one, which is 2x minus 7. So here's our 2x. We'll bring this down. And our minus 7. We'll bring this down. All right, we don't need this. We won't need any of these down here either. Okay. So we're going to go ahead and fill it. We're going to multiply 3x squared times 2x, giving us 6x cubed. We'll multiply 3x squared times negative 7, giving us negative 21x squared. We'll multiply x times 2x, giving us 2x squared. And we'll do x times negative 7, giving us negative 7x. We'll do negative 5 times 2x, making negative 10x. And then we'll do negative 5 times negative 7, giving us a positive 35. So now this looks very similar to what we have up here in this step. So we're going to write everything out. So I'm going to bring this up just a smidge. I want to keep this blue answer in view though. We're going to write our first row, 6x cubed minus 21x squared. We're going to move to our second row. That's a positive, so plus 2x squared minus 7x. And we'll do our third row, minus 10x. And that's a positive, so plus 35. This looks completely identical to this row up here. So just like that row up there, we have like terms. And we have another set of like terms. So we'll bring down our 6x cubed. And we'll do negative 21x squared plus 2 is negative 19x squared. And then negative 7, take away 10 more, is negative 17x. And bring down our plus 35. So you can see we still got the same answer. So method, whether we did the distributive property method or whether we did the table method, we still came up with the same answer. So there's one more way to do it. So I'm going to bring this back down. We're going to need more room. So we'll switch out a piece of paper for this. We're going to go ahead and write down this final way to do this. And this is called the standard multiplication method. Standard multiplication method. It's like using back in the old school days, back when you learned how to multiply. So when you do this, you always put the larger polynomial on the top, and then the smaller polynomial on the bottom. So since a trinomial is bigger than a binomial, we'll put the trinomial on top. So 3x squared plus x and minus 5 on the top, and we'll put the 2x minus 7 on the bottom. So remember the old school multiplication back in the day? Remember you had to like multiply these little guys together, and you would say. So we're going to do that same method that you guys have learned to do. So how this method goes is we're going to start by taking and multiplying our 2x times everybody up here, and then we'll multiply our negative 7 times everybody up here. Alright, so we're going to first here. So remember in old multiplication, I'm going to do a simple one over here. Let's do, say, 312 times 21. So now, tell me, if you can, Heather, what number would we multiply first? That is correct. We'd multiply 1 times 2 and we'd get 2. Alright, so let's follow that same pattern. So we'd multiply negative 7 times negative 5 and get a positive 35. Correct? So then we'd multiply what next, Heather, over here? You're right. We'd multiply 1 times 1, which is 1. So now we're going to multiply negative 7 times this positive 1x and get a negative 7x. Then after here, Heather, what do we do next? You're right. We'd multiply 1 times 3 and we'd get 3. So we're going to do negative 7 times positive 3x squared and get negative 21x squared. Now in this problem over here, what do we do next, Nathaniel? You're right. We're going to add a 0 right here, and then we start multiplying. 2 times 2 here. I'm going to put a 0 right here. Negative 5 and get negative 10x. And since 0 doesn't have a sign, I'll just put plus 0. So then what do? You're right, we do 2 times 1, which is 2. So we're going to do 2x times 1x, which is a positive 2x squared. And then here we'd multiply 2 times 3, which is 6. So then we'd multiply the same thing, 2x times 3x squared. That's a positive 2x. So then we're going to have 6x cubed. Well, what do we do now over here? After we've multiplied by the 1, we've multiplied by the 2, what do we do now, Ava? You're right, we add these guys up. So we're going to do the same thing here. We're going to add these guys up. And we start the back end. We got our 2, so 35 plus 0 is, well, 35. Then you would add 4 plus 1 is 5. We're going to add negative 7 plus negative 10 makes negative 17x. Then we'd add 3 plus 2 would be 5. And here we'd add negative 21 plus positive 2 makes a negative 19x squared. And then we'd bring down this 6 because there's no 0 there. So we bring down our 6x cubed here. So now we have our final answer, which is the same as what we had on the previous page. 6x cubed minus 19x squared minus 17x plus 35. So again, it doesn't matter which method that you choose to do or not to do. You're going to get the same exact answers. So that is all that you need to know for today's lesson. I hope you guys have a great day. If you've got any questions, please feel free to reach out to me. To remind, I'd be more than glad to answer your questions. Have a fantastic day.